So let's put that teleconnection into a better context here. Okay, so here it is a map that is kind of showing the usual consequence of an El Nino southern oscillation that happen across the world. So you can see these circles showing various things like marine life, floods, coastal erosion, droughts, coral reefs, tropical storms, and so on, all across the globe. Okay, so the first thing then is to remember again that El Nino causes a huge global perturbations. In fact, this is not showing the impact on the Arctic and the Antarctic, and there is evidence that the waves generated by this heat source in the tropics can reach all the way to the Arctic and Antarctic, right? No, it's not a surprise because waves can go wherever they want depending on what is forcing them and what is restoring them. So we'll see in the next chapter when we do waves that waves are generated by a perturbation, and if you push something it might not come back unless there is a restoring force. If it comes back, then it will oscillate. That's why we have wave, right? Nonetheless, here off of Australia you can see you get droughts and forest fires. In Indonesia you get droughts and forest fires. You get droughts over the Philippines, Japan, and so on. China, India are not shown so much here. The consequences all the way up. You can see the west coast all the way up. The marine life is impacted. Coastal erosion can be increased because of the storms associated. Because you increase the spread of the warm water, and the warm waters favor cyclones and typhoons and hurricanes, you have impacts on cyclones, tropical storms, shown here in both hemispheres, right? As I said, storms can be increased or decreased based on what happened to the temperature and what happened to the atmospheric conditions that can favor or disfavor El Nino, the cyclones and hurricanes, right? So you can see southeastern US has some floods shown here. The coral reefs are getting damaged all the way into the Caribbean, of course in the East and West Pacific, Nordeste region that I mentioned here in Brazil, in the southern Atlantic, all the way into East Africa, South Africa, India, and so on. So El Nino has global impacts, no doubt at all. We know it. We have very good records of it historically and in modern times. Happens through this atmospheric bridge where the waves and winds are changing in the atmosphere, and also so-called oceanic tunnels where ocean waves are transmitting the signal, remembering that the ocean moves very slowly. Sometimes ocean signature appears after the El Nino has already happened. For example, the Indian Ocean warms in February, March, April of the year following El Nino. If El Nino peaks in December, January, February of let's say 2015, then March, April, May, February, March, April of the 2016 will be warming over the Indian Ocean because you have perturbed the Walker cell and so on and so forth. So that warming then affects the next monsoon as well. So El Nino can not only affect the monsoon in the same year, but it also can affect the monsoon in the following year. So the teleconnections are complicated. Good news is if you can forecast El Nino, then you can forecast these teleconnections if they are always related, right? That's the goal of predicting El Nino. So the question then we will see is, are there El Ninos in the other oceans? If you have trade winds and upwelling and it's sloshing back and forth that causes an El Nino, then you expect that other oceans will also have this kind of sloshing back and forth in the zonal direction, right? So surely there are El Nino-like features also in the other oceans, and we'll discuss that in one of the next podcasts. Maybe that's the next one, maybe not, I'm not sure, but I'll definitely touch on it.